All right. So the first thing I want to do is talk about a piece of equipment that you've already used. You did it when you did the resistance experiment. You use your ohm meter, but I want to talk about the digital multimeter kind of in general. And if we had met face to face, we actually would have started out with this. Started out talking about the digital multimeter and the power supply. That would have been the very first thing we went over. And after that, you'd have done the resistor experiment. But since we didn't have the means to show the equipment, I wasn't able to do that. So I want to spend some time talking about the meter now because of everything you're going to use, by far, the digital multimeter is the most important piece of equipment. So get that out. You should have the meter there, your meter. I know you have it because you guys in one of the labs, you took a picture of it and you sent me a picture of it. And you also watched the video. You did some research on the digital multimeter. So let's talk about that. So if you have your pen and paper, you might want to just do this kind of as an outline and just kind of go through what we're talking about. Again, not writing down every detail, but just writing down the main points. And then later on, you can go in and kind of fill in some of the things that we talked about just from memory. You don't have to write down every detail. Basically, I want to know that you just kind of caught the major concepts and that you were present for this presentation. Again, if you have a question, you can either push the raise your hand feature. I guess you can't see it at the bottom of the screen, but you guys know it. You can push the little raise your hand thing, or and I can switch over to this screen and you can talk to me, or you can just send me a message through chat and I'll see it because I'm sitting right in front of the computer. So I'm going to start. So I'm going to switch off of this screen, and once I do that, I won't be able to hear you guys. So you'll have to send me messages. I use the raise hand feature to get my attention. So I'm going to switch over now and look at the digital multimeter. Now you should have your meter out, and you kind of look at it as we go through this. And again, I know you already looked at a video on it, and some of you might even have experience with digital multimeter, but I'm going to assume that you don't know anything, and we're going to kind of start from ground zero. Now this meter, I actually spent, I don't know, it might have cost me $20 at Lowe's. It wasn't very expensive. It's a basic digital multimeter. It has the functions that most meters will have the functions that's on this meter. You can spend a lot of money on the digital multimeter, and you can have a lot of other features that this one doesn't have. But any meter and every digital multimeter will, you can measure voltage, you can measure current, and you can measure resistance. There's some other features on here that I'll point out as we go through this, and your meter may or may not have some of these features, but the basic features it will have, and those are the ones I'm going to emphasize. So we'll start. First of all, there's two types of meters. This is a digital multimeter as opposed to an analog meter. Now, an analog meter has a needle that moves. It has a needle that moves. You've probably seen, or maybe you've seen analog meters before, but they pretty much got displaced by digital multimeters for several reasons that we won't go into here. Now, analog multimeters still do have a place in electronics. There are certain areas where analog meter can outperform a digital meter, but for what we're going to do in class, none of those areas are important for us to talk about, because for what we're going to do in class, digital multimeter is going to be the best candidate. So on my meter, and yours will be the same way, notice first of all these inputs right here. These are inputs, and these inputs are female inputs. And you know you're going to plug in your lead. Here's the lead, and this is the male end for reasons that hopefully is obvious why that's the female inputs and these are male ends. Every meter, every digital multimeter will have this input is COM, that stands for common. Common, either common ground or maybe a common connection. You can think of that if you want to as your negative polarity, but it's not quite right to think of it that way. But for what we're going to talk about, think of that as a negative polarity or common ground. So you know, in electronics, the color red and black are important. You probably know that from your car battery. If you ever change the car battery, or maybe you had to use jumper cables on the car battery, you know that you connect the red wire to the positive polarity, you connect the black wire to the negative polarity. Well, exactly the same applies here. Either with your meter or with the kit that you got from the school, you have these leads. So I have a pair of leads here. Let me just show one of these leads. And again, the lead has this male end on this end, and on this end here it has this clip. This is called an alligator clip. And the way you name these leads, this male end is called a banana, like a piece of fruit, banana. So this is a banana to alligator lead. You can name a lead by the end. Sometimes you'll have this piece on both ends. You'll call it banana to banana, or you may have this piece on both ends. It's an alligator to alligator. But for the meter, this is a banana to an alligator clip, and that's kind of nice because what actually came with my meter was not what I was showing you. What actually came with my meter, and probably came with yours, was this lead. This lead came with the meter. And this is really good for getting into tight places, because right here at the tip of this, the conductor is real sharp right there. There's a conductor there. So I can plug this into the meter, and I can get in there, and I can probe, and I can test with that point. However, if I have to make a connection to something, like this piece of wire, if I want to connect to that, all I can do with this is just kind of touch it against there to make contact with it. But if I want to get a good electrical connection, it's impossible to have a good electrical connection without having a good mechanical connection. And so that's where these alligator clips kind of come in, because with these, I can still plug this into the input here, and I can use this alligator clip clip on the wire like that. So I'm going to show the leads, not the one that came with my meter, but the one that came with your kit. Now I was mentioning the colors red and black, so you should have a red lead and you should have a black lead with your kit. And so if you think of the common on the meter as your negative, you plug the black wire into the common. So I'm going to plug the black wire into the common. Now, the digital multimeter, multi means what? Multi means many. And why do they call this a multimeter? Well, it's because you can measure, on this one, you can measure volts. You can measure, that's the omega symbol for ohms. And then there's an A here for amps, even though it's in milliamps. You can measure volts, ohms, and amps. Voltage, resistance, and current, and hence the word multimeter. So how do you measure, say, voltage, or how do you set this up to measure voltage? How do you set it up to measure resistance? How do you set it up to measure amperage or current? Well, no matter which one of these functions you pick, you're going to plug in the black wire to common. On any and every digital multimeter, you'll have that common connection. So no matter what, you're going to plug your black lead into common. Once you plug your black lead into common, where you put the red lead depends on the kind of meter you want. If you want a volt or ohm meter, you're going to put it, now while I'm doing this, you look at your meter, because your meter might be a little bit different. It might be a little different. So if you look here on this meter, if I plug into this input, I can measure volts, I can measure ohms, I can measure current. Yours, and often the meters will have a volt ohm meter for one input and current for a completely separate input. The ones here in the lab that we use here at Cincinnati State are like that. You'll have like one input for voltage and ohms, and the second input for current. So look at your meter and see how it is. Is it like this one, where you just take your red lead and you put it into this input, and then you can measure volts, ohm, and current? Or is it like the ones here at the school, where you measure volts and ohms in one input, and you'd have to insert your lead into another input to get current? Often they're separated. So look at your meter to determine how yours is. Now, notice you might wonder, okay, well, it says here milliamps, and over here it says 10 amps max. So what is that? Well, both of these are current inputs, and the input here in the middle, that input, if you read on my meter, now yours is different, I'm sure, but on mine it says 500 milliamps max over this. And then over here it says 10 amp max. So if I'm going to measure from 0 to 500 milliamps, from 0 to 1/2 an amp, I'm going to plug that lead right here. If I'm going to measure anything over 500 milliamps up to 10, I'm going to plug it over here. Now let me pause for a second and talk about current. We all know what current is. We all know that current is the flow of electrons, flow of charge. But you may not have a feel for what is a lot of current and what is a little bit of current. 1 amp is a lot of current. Milliamps can kill you. Milliamps can stop your heart. So 1 amp is a lot of current. And here we have a meter that can measure 10 amps, which is a huge amount of current. So you look at your meter and see if it tells you the maximum current for your meter. It may or may not be stamped on your meter, depending on how much you pay for it. But look at your meter to determine, do you have these separate inputs? And if you do they have the maximum current marked? The max current here for this input, 500 milliamps. Max current for this input is 10 amps. Now, probably I won't say all the time. I'll say 99% of the time, you will be using milliamps. As I said before, 1 amp is a lot of current. So in this class, at least I can say in this class, you'll never, ever, ever use the amp. If you have a separate amp input, you'll never use that in this class. And you hardly will use it anywhere else unless you're measuring some really, really high currents. The other thing I want to point out on this meter, again, yours might be different, is that this is important. It says fuse right here. This input right here, it says 500 milliamps max fused. And over here it says 10 amp max, and again, it's fused. It's fused. So typically when you buy a meter, this input is fused. The low current input is fused, and the high current input often is not fused. And it's important to know if it's fused or not, because if it's not fused and you make a mistake on the high input side, the high input current side, then you destroy the meter. If it's fused and you make a mistake, all you'll do is you'll blow the fuse, and you won't be able to use the meter until you get in there and use the fuse. So you want to look at your meter to see if it's fused or unfused. Almost all meters on this low current input are fused. If for some reason yours is not fused, then you want to be extremely careful that you don't short it out. If you short it out and it's not fused, then your meter pretty much will be damaged. And as I said, most meters are fused, but if you pay like just a little bit of money for the meter, then it may not have a fuse on the low current input. So take your meter and go ahead and get your black lead and plug it in the common, as I have shown here. And what I want to do is set this up first as a voltmeter. So as a voltmeter on this meter, I see that the V is above this input. So I'm going to take the red lead and I'm going to plug it in to that input. So you get your meter, and I want you to do the same thing. The red lead into this input. So if you do that, then now your meter is set up as a voltmeter, or an ohm meter, or in this case, an ammeter, because I have the input that has all three of those quantities over it. Yours probably just says volts or ohms. Now, once you get this input plugged into the correct input, depending on the quantity you read, then you have to go up and you got to adjust this dial. Now, notice on the dial, like for voltage, here's my voltage. and I have another voltage over here. So this voltage right here, this scale, goes from 200, and that ohm is for milli, 2000 milli, 20 volts, 200 volts. I can measure up to 600 volts with this meter. And over here, I got this voltage. It says 600 volts, 200 volts. But look at the little symbol by here. I got a symbol here. It's like a little wavy line. And I have a symbol here. There's a solid line and a dotted line. I don't know how it's denoted on your meter, but on your meter, you probably have two voltage settings. One typically over here on the left and the other over here on the right. The difference between the two is the voltage on the left on my meter is DC voltage, direct current, which is what we're dealing with in this class. On the other side, where I have that little wavy line, that's AC voltage. So if I was measuring the voltage coming out of the wall outlet, I would turn it to this position over here, probably the 200 position. If I was measuring the voltage for, say, my car battery, I would have it somewhere over here on the left, probably here set at the 20 volt range. So that is true for voltage and current, but not resistance. What I'm saying is I have over here on the left side of this meter, these are all my DC settings for voltage. And I have over here, I have AC setting for voltage. And then when I measure current, I'm going to measure current, either AC current or I'm going to measure DC current. And that's going to be determined by where I have this knob set. So yours is probably different. You probably actually have it set off to where you have current on the AC side. Well, here you have DC current on my meter, but yours is probably marked differently. So I have a DC ampere. I see the symbol there for DC, but yours may be a little different. So look at your meter and determine how those quantities are. And what I want you to do is set it up for now as a voltmeter. Now I'll go ahead and turn this on. Now the other thing to note is the off position here. The meters here at in the lab have an off position at 12 o'clock and the off position at 6 o'clock. If you're not using your meter, you want to turn it to the off position. If you leave it on, then it has a tendency to run the battery down kind of quickly. So I'm going to set this up now. It's set up as a voltmeter. I'm not going to read any voltage yet because I don't have a voltage source. But I'll just turn this to this position here, and hopefully you can see here. Now I'm on the 600 volt range, so I can read up to 600 volts, from 0 to 600 volts. If I'm reading a low voltage, let's say I'm reading 6.5 volts. I can read that on the 600 volt scale, but what you want to do is start at the high scale and then start to scale down until you get a range that fits the voltage that you're measuring. You want to try to use as many digits across the screen as possible. So if I measure like 6 volts on the, I'm measuring say 6.5 volts DC, and I have it set to the 600 volt range, then I'm not going to use as many digits here as I would if I put it on the 20 volts range. So when you hook up a voltmeter, what you want to do is, if you know the voltage you're measuring, you can go ahead and dial that in right away. If you don't know how much voltage you're measuring, you always start at the higher range, and then you hook it up to what you're going to measure, and you scale it down until your meter, you're using all the digits on your meter. So you probably want to write that down. When you're measuring voltage, if it's an unknown voltage, start at the highest range. Right now I have it set at 600, and then you can move it down to the range that fills out the digits here on your digital display screen. Now, let's change this to an ohm meter for a second, and notice what happens when I change this to ohms. So my ohm setting, again, I have these ranges. So I have up to 20 meg, I got 200,000, 200K, I got 20K, I got 2,000, and I got 200. we'll talk about this in just a second. So if I switch this to the ohms range, notice what happens. I'm going to go down to like, so I'm down here at 200. Now look at your meter and notice there's a 1 here. Now your meter may have a 1 there. It may have an infinity sign. It'll be something other than 0. So when you see that on this meter, that 1 stands for an open circuit or infinite resistance. So hook up your meter and see what it displays. Is it a 1 there? Is it an infinity sign? What does it say when you have it hooked to a low resistance range and you don't have anything connected to it? That stands for open circuit. If I short it out by connecting the leads together, I take these leads and I connect these leads together, watch what happens to the meter. It goes to 0, well, almost 0. So we're reading a small resistance here, 0.3 ohms, which is actually the wire resistance of the leads. So this is a pretty good meter to pick that up. So I'm measuring 0.3 ohms, which is the lead resistance of the leads, the wire resistance of the leads. But basically that stands for 0 ohms. So you hook your meter up and do the same test I just did, hook up the leads together, short them out, and see if it will measure the lead resistance. If it says 0, that's okay. If it says 0, if you get a small resistance reading and you're actually measuring the lead resistance, that's a pretty good meter to do that. So hook up your meter and do what I'm doing right now. Now, something else here. The ranges here, you've already kind of played around with that when you did your resistance experiment. But look right here, there's a little symbol right here, and you probably have the same exact symbol or one very similar to this on your meter. So find this symbol right there. That symbol right there is to check, it's called continuity, a continuity checker. And the way you do that, let me disconnect my leads here for a second. If I disconnect my leads and I move this to that position, I set my meter up to check continuity. And continuity, what that is it'll send a current through the circuit, and if the circuit is continuous, it'll ring a buzzer. If it's non-continuous, it will not ring a buzzer. So if I hook these leads up together, I don't know if you'll be able to hear this or not. You probably can't hear it, but right now it's buzzing. I don't know if you can hear it. But hook yours up, turn it to the position where you have a little, this is the universal symbol for sound. Hook it up and see if you get the buzzing sound. So mine is buzzing right now, but I don't know if you can hear it or not. I'll move it closer to the camera, and you might be able to hear it. So my buzz is pretty small. Okay, so the continuity checker is important. So why do you have a continuity check? Again, to see if circuits are continuous. So I'm going to turn this off for a second. So the word continuity means continuous. And if you want to check to see if the circuit is continuous, then you can use that continuity checker. Now, that feature alone is used often when you're using a meter to troubleshoot. So let me give you a little example of that. Let's say that you're looking down at my living room in my house, and on one side I have a stereo system, and on the other side I have a speaker. And what I do is I run wire across the room, so that I get sound out of the speaker. But what I'm going to do is I'm going to put a piece of carpet over it like that, so I can no longer see the wire. So the picture I got is this, where I have the carpet, I got the stereo, and I got the speaker, and I can see the wires coming in here, and I can see the wires going over there. But when I hook up my stereo, it was working before I put the carpet down. But then I put the carpet down, I no longer hear music coming out of my stereo system. So I figured that when I put the carpet down, maybe one of the staples cut through the wire, and I broke a wire, and I can no longer hear music coming from my stereo. So how would you check that to see if I have a broken wire? So you would do what we call a continuity check. And there's basically two ways to do that. I want to first disconnect both components. So I'll end up with just bare wire. I'll end up with wire here and wire here. And one way to do it would be to just take my leads, put my continuity checker, connect my continuity checker, and connect the lead here and the lead there, and the lead here and the lead there, and I can tell which wire is broken. If I have that buzzing sound by connecting here and here, I know I have continuity, the wire is not broken. If I connect here and here and I don't hear the buzzing sound, I know I have an open circuit. And that's the simplest test you can do with a digital multimeter, the continuity tester, continuity check. So that's what that symbol is. That's what it stands for, continuity. And your meter probably has that symbol on it. Now there's another symbol here that I don't want to go into too much detail on that, but this little symbol here, you may have that on it also. That's called a diode, a diode. And you heard of light emitting diodes, an LED. Most people have heard of LEDs, light emitting diodes. Well, a diode is a device that acts like a valve, a one-way valve for electricity. A diode allows a current to flow in one direction and not in the other direction. And they have many applications, which we won't go into in this class. But this meter has the ability or capability to test diodes. Now, we're not going to talk about diodes, so I'm not going to show you how to use that feature. But just know if your meter has that symbol on it, you have the ability to test diodes should you ever need to do that. Now, let me change from the continuity connection back to my resistance connection. And again, notice that I'm measuring 1 ohm here. That 1 stands for open circuit. And all that means is that my leads are not connected. Let's say I want to make a measurement. Now, you guys measured resistors already with your meter. If I want to measure a resistor, here's the wrong way to do it. So I have this resistor here, and I want to measure it. So I'm going to pick it up like that, and I'm going to pick up the other lead like this. And actually, what I'm doing is okay, because both these leads are insulated. The actual clip has this vinyl or rubber insulation on it. Now, I don't know if yours has that or not. The same with the other lead that actually came and has this insulation on it. But some leads will have only metal on it. If you hold it like this when you're measuring resistance, that will be the wrong way to do it. The leads here in the lab, I'll show you the leads in the lab and you'll see what I'm saying. So here's a set of leads in the lab, and you can see that the alligator clip does not have that vinyl jacket on it. So if I were to hook this up to this, like that, and then take the other lead and hook like that, to measure resistance, if I'm holding this in my hand like this, then that would not be the correct way to measure, because I'm measuring the resistance of the resistor, but also if I'm touching it, I'm adding to it the resistance of my body. So if your alligator clips are actually bare like these, you either want to hold it with one hand, or even better, just kind of lay it down on the table when you make a measurement. If, on the other hand, you have the vinyl covering the alligator clips, then it would be okay to hold it, because then your body will be insulated from the resistor, and the measurement will be only the measurement of the resistor. So if you got the leads from the school, they probably have this insulation on it, but if they slipped up, if they gave you leads like these, just make sure when you're making a resistance measurement, you're not touching the actual metal part of the lead. If you are, you'll be picking up your body resistance. And depending on the size resistor you're measuring, that can kind of throw your measurements off. Now, I have a resistor hooked up to this. You can see it's hooked up. And this is measuring 1. So why is that measuring 1? Well, it's measuring 1 because the range I'm on here is too low. So if I move this up to a higher range, when you measure resistance, you can move that up to a range until you see the reading that you're looking for. So I'm going to move this up to a higher range, and now I'm starting to read. So right now I'm on this is the 2,000 ohm range, so I can read a maximum of 2,000 ohms. When I was down here on 200, the value of the resistor is higher than 200. So it's higher than this range. So that had an open circuit. I move up to the next range, 2,000, and I can read up to 2,000 ohms. And since this resistor is 1,505 or 6 ohms, then I actually get a reading here. If it was higher, let's say it was higher than 2,000, that 1 would still remain on the screen. So when you measure resistance, some meters are auto ranging. And what that means is if your meter says auto ranging, either on the meter itself or in the documentation, all you got to do is hook it up and it'll automatically measure the resistance. If it's not auto ranging, then you got to actually manually set it to these ranges to figure out what size resistor you're measuring. So auto ranging meters, of course, are way more expensive than the manual ranging meters. So you may or may not have an auto ranging meter. So that's something else to learn, to write down, is when you measure resistance, you can start, doesn't matter if you start high or start low. I usually start low, and I'll see some kind of indication on this meter it's a 1 that I have an open circuit, and I'll move the range up until I get the proper resistance value. Whereas when I was measuring voltage, I didn't start at the lower range. When I measure voltage, I start at the highest range, and then I move it down until I figure out if I have an unknown voltage I'm measuring until the reason you want to do that is if you have a really, really high voltage and you start on a low range, you can actually damage your meter. So when you measure resistance, it doesn't matter. You can start on the high range or low range. I think it's smarter to start on the low range and then move it up until you get a reading. But definitely when you measure voltage, always start on the higher range. If you're measuring an unknown voltage, always start on the highest range and then move it down until your screen is full with digits. If you know what the voltage is, of course, you don't have to do that. You can just set it right to the range. So if I know I'm going to measure my car battery, I know car batteries are 12 volts. I'm just going to set it right to that range, that 20 range. I know what that is. But if I have some unknown voltage, voltage X, I'm going to start right here and then move it down until I figure out the value of voltage X. So now on your meter, here's where things will get a little confusing. This meter's different, as I said before, because on this meter, I have the same input for voltage, ohms, and current, but on most meters, you don't have that. One input would be for volts and ohms, and then we'll have its own separate input for current. So yours is probably like that. Yours probably has a separate input. But if you do have something like this, then it's a little easier to deal with. If you have a separate input for current, all that means is when you want to set this up as an ammeter, then you got to move it from the volt ohm input over to the current input. You never ever move the common wire. That's always connected up in common no matter what you're measuring. So I'm going to turn this off because what I want to do is I want to talk about your trainer. Now I got one problem, guys, is that the trainer is too big to set on the screen. So I can only show parts of it at a time. But before I do that, I need to talk to you about the prototype board. The prototype board. So this prototype board is what you have on your trainer. You actually have two of these on your trainer sitting right next to each other. So get your trainer out right now. Get your digital trainer out. Open the hood, the lid to it, and look at that trainer. Look at the white pad on the trainer right now. If you're looking at that white pad on the trainer, you'll see two of these things right here, right next to each other. This is called a prototype board, called a breadboard, a quick build board. There's a lot of names for it. Most people call it a breadboard or a prototype board. But you have two of these on your trainer. Now I'm going to see if I can put the trainer here where you can see it. So this doesn't fit on this too well, but what I'm saying is this board right here, this space, this thing right here is your prototype board. And so if you look at this, this is one board, and then on the other side I have another board. So I actually have two of what I'm showing you on the picture. Now, you have to understand how this board is laid out. So let's talk about this. If you're looking at your trainer, just focus on one of those boards, either the top one or the bottom one, either one of those boards. The first thing you'll notice is there's a little valley right here. There's a valley right here. What that valley does, it divides that board into, the way I have it oriented here, into a top and bottom. Okay? So that valley cuts this into a top and the bottom. So what I have here are strips of wire that run behind this board. And I don't know if you can see it or not in the camera, but like number one here, they have this whole thing circled. You see that? This whole thing is circled. And what that means is there's a wire behind that board that runs all the way down to the end here. There's a wire that runs all the way down to the end. So if you plug anything in any one of these holes in that circle, marked number one, then it's connected to itself. Now, if you don't understand that, that's okay, because I'm going to show you, and you're going to test it with your meter here in just a second. But what I want you to know, what I want you to focus on is this valley right here. So here's what I have. I got number one here is circle. This row is circle. And then number four down here, this is circle. Those are called rails. Rails. So let me come over to here. Let me try to explain it like this. So what you have the board. And then you have that valley. And so that valley right here divides this into a top and bottom. Now, I'm talking about this row right here, circle number one. There's a set of holes right here that go all the way down. All the way down. And behind that is a wire that connects all this together. So I got that right here, and I got that right here. So there's two rows of these that are connected all the way together. And those are called rails. And what you do is, if you want to connect up power to this, a battery or your power supply, then what you can do is you can take your battery or your power supply and you can connect one in here and one in here. Let's say that was, let's just say it was 10 volts. That was 10 volts. Then now you have 10 volts all the way down these two rails. So you can connect to these and use all those holes all the way down. So all that does is extend your power supply all the way down. Now I want you to see what I'm talking about. So here's what I want you to do. Get your digital multimeter and set it up as a continuity checker. Go ahead and do that now. Get your digital multimeter and set it up to check continuity. How do you do that? Well, all you do is take your multimeter, you find the audio indicator, whatever position that is, you hook up your leads, and if you turn that to continuity check, and I don't know if you're going to hear this or not on the camera, but when I touch this together, it buzzes. And that buzzing means that I have a connection. If I break this apart, that buzzing goes away. Also, you'll notice the meter reading. If I'm looking at this, if I connect up, that goes to 0, meaning no resistance or short circuit or continuity. If I break it apart, it's a 1, meaning there's not a continuous connection. So set your meter up to measure continuity. Now, why do I want you to measure continuity? Because I want you to prove to yourself that if you connect your meter, let me find my, if you connect your meter to, if you connect your meter to any position here in that row 1 or row 4, that there's continuity all the way down to the end of this. If I go over here to something outside of that circle, then there's no continuity, indicating no connection. So what I want you to do is get your trainer out. Now again, I can't show my whole trainer. It's too big to fit under the camera. Get your trainer like that, and hopefully you got a piece of wire. I don't know if they gave you wire or not. If they gave you wire, you should be able to connect, say like right here. This is the rail I'm talking about. And actually on this trainer, there's 2 rails. There's one right here on the top. That rail runs all the way down to the bottom. And there's a second one below it that runs all the way down, all the way across. One has a plus and a minus on it, showing you that you can connect. With 2 rails, what you can do is you can have positive and negative voltage above and positive and negative voltage below that little valve. But what I want you to do is stick a wire in, say that first input. Stick a wire there. So I got the wire here. And then take another piece of wire and stick it maybe right next to it or a few holes away from it like that. I don't know if you can see that because the light's kind of hitting it, kind of funny. But I'll try to bend these over so you can see it. So you can't actually see the wires going in there, but I have a wire going into this hole and a wire going into that hole. And now what I'm going to do is I'm going to take my meter, which I have set as a continuity checker. I'm going to connect this up. I'm going to connect this up. And you probably can't hear it on the camera, but you can definitely see on the meter, see if I can get both of these in there, then my meter is reading 0, meaning there's a connection between these 2 points. And I can move this all the way down. So I move it all the way down. If I move it down to here, again, 0. Goes back to 1. I move it down to here, 0. I can move it all the way down to the very end, and it's still reading 0, meaning there's a connection all the way from here, all the way down. But if I come over next to it, I'm on the left side of it now, there's no connection. It's still reading open circuit, indicating that there's no connection between the rail on the left side of it. So I want you to just kind of do that. Prove to yourself that this rail is common or connected all the way down to the end. If I go right next to it, it's not connected. So what this picture is trying to show you that I had on the screen before, just give me a second, I'll put it back. So what this picture is showing you is the common connections of the rails. So on this particular board, that rail starts here, and there's a common connection all the way down to here. So anything I have plugged into any one of these holes is connected to anything else I have plugged in any other hole that's in that same circled area, and the same on the bottom here. Whereas if I look at these, the connections start here for number 2, and they go down, they stop right there. They don't go across that little valley. So that's why I started with that valley. The valley indicates a break in the board, and it's not a continuous connection all the way across. It's important to understand that, because when you want to make a connection, well, let's say I want to connect resistors in series. So here's how I would do that. Look at this board. Let's connect it. So I'm actually using the rail now. Here's my power supply. I have a wire ran over here and plugged into that first input, that first hole. Remember, this rail runs all the way down there and all the way down there. So for my power supply, I run the wire over and put it in that first hole, and now current can run through that rail to get to my resistor. So this resistor is actually connected to this power supply through that rail. And the same on the bottom. I have the negative side, the other side of the power supply plugged into that first hole. So anything plugged into any of these holes is connected to the power supply. So in this picture, I'm using the rails here to provide power to my resistors. Now, hopefully you can see, if you look at this, it's showing that any of these columns going this way, see that circle, it's kind of like a vertical circle. All of these are common. That's just one wire running all the way up. I can shade that in and say that these are all connected like that. They're all connected. And these are all connected together. All those columns are connected across like they're all connected. So when I actually want to connect resistors up, look at how I'm doing that. Look at what I'm doing here. I'm connecting the resistor, that top resistor, to the power supply through that rail. And I'm connecting the bottom resistor to the power supply through this rail, but they're connected to each other because if I'm in that vertical column, then all of these are connected together like that. They're all connected. So now here, these are actually connected because there's a connection, a wire connection like that and like that. Okay, so I don't know if that makes sense to you. Hopefully it does. But what you can do is this. If you have your trainer, get your trainer out and go ahead and connect this circuit up. It doesn't matter which value resistors you use. I don't really care right now. But get your resistors out, get 3 resistors out, and on your board, see if you can connect this up. Connect up. You don't have to connect power up. We haven't talked about power yet. We'll get to that in just a second. But go ahead and see if you can connect this up. Now, before you do it, before you connect it up, What I want you to do, get 3 resistors. So get 3 resistors. It doesn't matter what size they are. Get 3 resistors out. Once you have your 3 resistors out, then what I want you to do is take your digital multimeter and put it on ohms. Set it up to measure ohms. And what I want you to do is get the ohmic value for each resistor. So go in here and take this first resistor and get the ohmic value of it and write it down somewhere. So get the ohmic value of the first resistor, get the ohmic value of the second resistor, get the ohmic value of the third resistor. Get 3 resistors and measure the ohmic value of each one. And write it down. And once you have the ohmic value of each resistor, then I want you to see if you can build this circuit on your prototype board. So I'll give you a second to do that. And while you do it, I'm going to do this on mine. All right, so I've measured my 3 resistors with my meter. And I got one that's 327 ohms, one that's 148, and another that's 148. So I got my 3 resistors there. So that's what I want you to do. Measure those 3 resistors and write down what they are, the ohmic value of each resistor. If you've done it already, the next thing you'll do is I want you to add these up. So get your calculator out and add this up to find the total resistance. So take your meter, measure the 3 resistors, and then add it up. So on mine, I got 327, 148, 148. I got 623. I don't know what I just did. Hold on, I just did something to this. Okay, so I got 623. So figure out what yours is. And once you've done that, what I want you to do is to now hook this circuit up on your breadboard. See if you can figure out, if you understand the connections that I talked about on the top here, if you understand those connections, you should be able to hook this up. So hook that up. I'll give you a minute to hook it up. Tim, did you have a question? Wait a minute. Let me switch over. I gotta switch over to here. Okay, Tim, you had a question?
Yeah, on mine, when I measure in ohms, it's coming up as K ohms. So my measurement was like 2.29 K ohms. Is that the correct setting?
Yeah, so actually, that is a very good point. I'm actually glad you said that because I forgot to talk about that. So in some meters, you got to be careful because it might. Oh, okay, now let me go back to the projector for a second. Hold on. Okay, so Tim said that his is coming up as K ohm. So on some meters on the screen, like on the ones here on lab, they'll have a little, if it's on K ohms, they have a little K ohm right in the corner somewhere. So it might read, in his case, it read 2.2. Now you might think that's 2.2 ohms, but you'd be wrong. It's 2.2 K ohms. So it would be 2.2 K ohms is 10 to the third. So it's really 2,200 ohms. So your meter might be like that. Look at your meter real close. You might have a little bitty K ohm indicator that lights up, or it may actually be printed on the meter itself. So yeah, Tim, thank you for that. You want to be careful that you look at that. The meters here in the lab are like that. They're in K ohms. So when you read 2.2, students might write down 2.2 ohms when in fact it's 2.2 K ohms because they don't see the little LED, the little light indicator lit up over here. So you're going to be cognizant of that. Is your meter reading in ohms or is your meter reading in K ohms? So Tim, you would be correct to write down K ohms. So that's a really good point. Thank you. Now guys, I'm going to give you one more minute to hook your circuit up, and I'm going to show you how to hook it up. So go ahead and hook that circuit up, and then I want you to snap a pic. Well, I guess you can snap a picture of it at the end. I don't want you to take too many pictures. But at the end of this, I want you to take a picture of your build so I know that you're doing this, and that's how you're going to get credit along with your report that you're going to write for me. So go ahead and build the circuit. I'll give you about another 2 or 3 minutes, and then I want to build it together with you. All right, we'll go ahead and build this real quick. So I got my 3 resistors here, and let me switch back over to my document camera. So I got my 3 resistors here, and I did my math. I had one resistor that was 327, one that was 148, and another that's 148. 623 ohms is what I got. So I want to build this circuit right here on the trainer. So let's see if we can do that on the trainer. So what you should have done on your trainer, choose either the top board or the bottom board, doesn't really matter which one. And I got to try to get this in here, so give me a second. All right. I tried to all right. Try to turn that light out. I think you can see the board a little bit better now. So what I got to do is, in any order, I'm going to plug my resistor into one of these rails up at the top. So any rail, I'll just plug it up there in any rail and bend it over to one of these columns. Okay, so now I'm connected to this top rail right here over to here. So to connect the next resistor, I got to connect it in this column right here. I can't be on this side of it or this side of it. It's got to be either in that hole, that hole, that hole, or that hole, right below it. Any other hole to the left or to the right is not connected, because remember, the way those run, they run, I don't know where my paper is now, but they run up and down. So these run up and down. So if I want to connect, I got to connect anywhere in that circle. I can't be to the left or to the right, so they run up and down. So the next resistor, I want to connect right here. Bend it over. And now these are connected in the board because they're in the same column, that same row. If I had it over here or anywhere on this side, it wouldn't connect. But because it's in the same column, I call it column, then it's connected. And so I'm going to do the same thing with the other resistor, to connect it on the other side, and then bring it back to one of the rails over here on the other side. So I'll connect the other resistor, let's say right here, and then bring it back to one of the rails. So hopefully you can see in the camera, I'm connected to this rail, one end. It just comes over to one of these columns. The columns are actually marked 60, 55, 50. The columns run this way, and they're actually numbered. So I'm over here at like, I don't know what number that is, but what's this? 60, 55, that's probably 45. So this is number 44 probably. Anyway, it doesn't matter. I'm connected here to that, to the board here, and now over here I'm connected to that column. Now the way you know if you're connected or not, since I actually calculated my total resistance, then you should be able to hook your meter up from here to here and read the sum of those resistors, because of course you probably recognize you just hooked up a series circuit. So go ahead and make this connection if you didn't already do it. Connect the way I'm showing you here. You don't have to use the same columns and all that I'm using. What you do, you need to using it the correct way. If you do it correctly, then we calculated the total of these three would be 623, or whatever yours is. Then what you can do is take your meter and actually measure to see if you did it correctly. Take your meter and put across the whole network to see if you get something close to what you calculated. I calculated 623. And so let's measure to see what the total is. I don't know if you can read that, but I calculated 623 and I got 623. Now, if you're reading a 1, that means that, or if you're reading an open circuit, that means you don't have it in the common row. You got to have it in the common row. That's why I want you to do this exercise to see how those columns, how they run. So right now, you should be reading the total resistance of whatever you calculated it to be. You add, somebody just texted and said everyone is very, okay. You measure each resistor, you put all three together, so you should be reading the sum of the three resistors. So is everybody getting that now? Is everybody seeing that? Anybody have any trouble measuring the total resistance? Is it making sense? All right, well, leave it hooked up on your board, but I want to talk about a couple other features on your board. Take your multimeter and change it to a voltmeter. Take your multimeter and change it to a voltmeter. Now, how do you do that? Well, on most multimeters, all you got to do is just change the setting. So here, make sure that you're in the right input. You're in common, and your red input is the input marked V. And then you just change this to the voltage scale. And then what I want you to do is to look at your trainer. Let's look at the trainer and talk about a few things. So on the trainer, you have a couple outputs. I don't know how well you can see this in the camera, but I want to talk about a couple of these outputs. So the ones that you're going to be interested in is this one right here, the black one. Now the rest of these are for other classes. So I won't talk about these other ones, but just this common right here. So that's your negative. Consider that to be, if this were a battery, that would be your negative, your common. And then your output's going to be up here. You see a plus V and a minus V. You see that? So if you connect, let's say the black wire in your meter to here and the red wire to here, then you should be able to adjust the voltage. So that's what I want you to do next. Let's adjust the voltage. So to do that, you may need a piece of wire to stick into this little hole right here, one of these holes. You got to have a piece of wire. So I have wire here at the lab, so it's easy for me to just get a piece of wire to stick in there. So I have this wire here, and I can just stick it in here like that. Now, if you don't have wire that'll go in there, then what you can do is get one of your resistors and just stick that resistor in there like this. And use the resistor as a wire. When you connect to it, though, you don't want to connect to this side of it. You want to connect to the part that goes in the hole, so it ignores the rest of the resistor. So if you don't have wire at home where you are now, just go to your bag of parts, get a resistor out. And what we're going to do is use the wire on the resistor to connect to. You can stick the resistor in any one of those holes, and we'll just connect right here with your clip. Let me move that down in the camera. So if you have wire, use wire. If you don't, you can use a resistor. I got wire, so I'm not going to use a resistor. I'm just going to stick this in here. So the way to look at this, and the only thing you have to concern yourself with is three things. Right here is your positive volt output. Right here is your ground. And then at the very bottom, there's some knobs down here. One that says positive V and one that says negative V. So the positive V is going to be the one that you're concerned with. That voltage adjusts the voltage here. If it's a positive voltage adjust, the voltage here. If it's a negative voltage adjust. So what you're going to do is take your meter, set it up as a voltmeter. And once that meter is set up as a voltmeter, take the black lead of your meter and connect to ground. So I took the black lead of my meter and connected to ground, and the red lead of my meter, I'm going to connect to that positive V at the top. So my red lead of my meter, I'm going to connect to the positive V at the top. If you don't have this piece of wire, as I said before, then all you got to do is get a resistor, stick the resistor in the hole like that, and then just connect your red lead to the wire on the resistor, and then you're connected to the supply. But I have a wire, so I'm not going to do that. You may or may not have a wire, so you might have to do it. I have an actual wire, so I'm just going to connect the wire in there and connect my meter to the wire, and now I'm connected. Now, to show you, this is on volts, so I'm going to turn this down to like, I don't know, maybe 20 volts. And now when you turn, I don't have this plugged in. So plug it in. You got to plug it in to get it to work. Turn it on. And when I turn it on, when I adjust this knob at the bottom, you see what happens? My voltage goes up. I don't know if you can see that. My voltage is going up. So make sure you can do this. Make sure you can adjust your voltage up. And it goes up. I don't know how far it goes. Let's see. So right now it's a 1. Now why is it a 1? Well, I was at 19 volts. My scale is on 20. So obviously this is above 20. So what I got to do is move it up to the next highest range, which is 200. So if I move it up to the next highest range, I should get my value back. So see, I was at 20.9, so that's above 20. So it went out on me. So now I can go back up and see how high this goes. So I got it all the way clockwise. I'm reading 20.9 volts. So that's a 20 volt power supply you have in your trainer. Now, what I want to do is I want you to set your voltage to 10 volts. So back it down and set it to 10 volts. So back it down.
Yeah. You could take that one off and.
That's set at about 10 volts. You don't have to be right at 10. You kind of
Those are
close.
the ones I got from this lady that's like called.
Yeah, I'm set at 10 volts.
Something she does all
I'll
like.
give you a second to set your power supply to 10 volts.
But that soap question company is off the Etsy, I
If
think.
you have any issues, go ahead and use the raise hand feature. If you're not following this, or going too fast, if you don't see what's going on, send me a message. I'll give you a few minutes to just do what I'm doing here.
Don't run when the gas goes up here about 9 o'clock.
9 o'clock.
Maybe earlier than that.
8 o'clock.
But my brother had to get some Dollar General when we were camping.
What was that, Timmy?
School stuff. Well, they have their own website.
All right, so
That's $22.
once you get it to where you have your supply set at 10 volts, I'm gonna move this.
SoFetch company. Just type in SoFetch dog collars.
Once it's set at 10
Does
volts,
not
I'm
have
gonna take my
Patrick's
meter out.
Patriotic Floral leashes.
Then what you wanna do is, here you're gonna need wire, so I hope you guys got wire, because what I wanna do is move the 10 volts over so it connects to that first resistor. So I'm gonna connect it up to this rail. Like that. So I don't know if you can see it. I think you can see it in the camera. So I have this wire going from my positive voltage out over to that rail that resistor is plugged into. So in effect, what I've done is I've connected my resistor to here, to the positive voltage. If you can't do that, then you might have to take this resistor. If you don't have wire, you might have to take this resistor and just stick it over there like that and move it over to the board and just kind of move your whole circuit over. But you can get them to go in at the same time. I don't know if the camera will focus on that. What I do is I have the resistor right here. One end is in my positive V and the other end is over in the board. And I can move these resistors over and have that same circuit. So if you don't have wire to make the connection, you may have to use the actual resistor to connect. Now, they gave me this wire in the kit, so you guys got wire, but I don't know if you stripped it. You got to strip it. So let me connect this back up, and let me just show you. We'll connect it back up, and what you can do, you can take this wire, and you should have some wire strippers. Well, these wire strippers are brand new. So you got these wire strippers. And if you got the wire strippers, I hate to open these up, but I guess I'll have to. But you got the wire strippers. There's a lock on here somewhere. There's a lock. You can unlock these. But you can take this wire. I'll just take one wire here. Actually, I can show you on another piece. So you pull one of those wires off, and then right at the tip of that, you'll see that when you close that, there's still a little hole there. When you close your wire stripper, there's still a little bitty hole right there. There's a blade here, so that's for cutting wires. There's a little hole there for stripping wires. So what you can do is you can put this wire in there so it's just in that little hole like that. I don't know if you can see the tip of that. I'm going to tilt it back towards me a little bit. Let me see if you can see the angle. So it's not parallel, it's tilted a little bit like that. So I'm going to tilt it back and then just pull it and it strips it. You see that? So I put it in there like that and clamp on it, but it's not parallel. I actually twist it a little bit. So it's kind of at an angle. Then I can just pull it like that and I strip the wire. And then you can use that in your board to make these connections. So then you can just take a wire and go from here over to here, if you strip it. So I don't know if you guys have stripped your wires. If not, I'm gonna give you a chance to do that. Because what I want you to do is to connect this up to power. So you got one here, and you gotta have the other one over to this, the negative here. So I'm gonna take the other one and connect to the rail right here. Now when I connect to this post, you can actually unscrew this. This thing will unscrew. Don't take it off, but it'll just lift up. And then the second wire, you can just stick it up under there and clamp it down on top of it. And there should be a little hole in there. There's a hole in there. If you use a hole, you got to make sure that you don't get the insulation under the clamp. You can either just stick the wire on the side and clamp it down, or you can stick it in the hole, but just make sure you got a good connection to it. So now my circuit is hooked up. I don't know if you can see it in the camera, but I got my my positive wire here, I stripped the wire and I ran it over to that rail. And I got that resistor plug in the rail. So they're connected through the board up to that point. And then my resistors are all connected in series through the board. And the bottom resistor is connected to that wire through the rail, which comes back around and goes to the negative terminal. So see if you can hook that up for me. See if you can hook it up, just like I'm showing you here on the board. And you should recognize that as a series circuit. I'm gonna give you a minute to do that, and I want you to push this aside, and we're gonna do something else real quick. Don't disconnect it, but just, your power supply should be set at 10 volts, and you should have this circuit hooked up. So I'm gonna give you about another 3 minutes, and then we're gonna move to the next part of the lab. Okay, guys, now for the next part of the lab, what I want you to do, just kind of set your circuit aside. I'm gonna move this out of the way. And you'll need a piece of paper. And what I want you to do is the circuit we just got through connecting on the board, I want you to solve it. I want you to draw the schematic using the symbols that you learned in the course. Draw the schematic of the circuit, write down the values that you have, and I want you to solve the circuit. Now, what do I mean by solve the circuit? When you solve a circuit, you find the current in the circuit, in every part of the circuit. You find the voltage across each resistor. You can find the power, although for this, I am not asking for power. I want you to solve the circuit. Draw the schematic of your circuit with your resistors. I want you to solve the circuit. Find the current in the circuit. I want you to find the voltage drop across each resistor. That document that you're actually drawing, I'm going to have you submit that as part of your report. So make sure it doesn't have to be perfect, but just make sure I can read it. You're just not writing it on the back of a napkin or something. So I'm going to give you a minute to do it, and we'll do it together. I'll do it with my values. Somebody's asked me to mute. Let me see if I can mute. How do I do that? Uh, okay, I'm assuming that it's quiet now. Somebody asked me to mute, but I didn't hear anything when I switched over. That was at 7:29. All right, so you guys just keep working. But what I had was I had these three resistors. So I'm going to use these values, and I'll just call one, I won't name them because I didn't really keep track of them. But what I'm going to do is draw the circuit. So we have a power supply that I'll represent as a battery. We have three resistors. And so I'll call it R, R, and R. I don't know which ones they are, so I'm just going to write this. It's my 327 ohm. I got 148 ohm. And I got another 148 ohm. I set my power supply to 10 volts. So that's the circuit I want you to solve. Now, I've already got my total resistance because I measured that. So I know my total resistance is 623 ohms. So what you got to do is find the current, and if I call this R1, R2, and R3, you got to find V1, V2, and V3. Now, I may not have these resistors named right, but it'll work out in the end, so I'm not really concerned about that. Of course, to find this is going to be V over RT. So I got 10 volts dividing by 623 ohms. Let me get my calculator and do the math. And I come up with about 16.1 milliamps. So I get 16.1 milliamps. So in your diagram, you're going to show your current 16.1 milliamps is what I got. Of course, you got something different. I got 16.1 milliamps. And then I can get each voltage drop. Now, when you're doing voltage drop, I know that V equals I times R. But since this is in milliamps, if I write that in K, remember what I said in the class, if my current is in milli and my resistance is in K, then the milli and the K will cancel out and the math's a little easier. So for this first one, for V1, it's going to be 16.1 milliamps. These are my values. And I'm going to change that to K times 0.327 K ohm. And then for V2, I'm going to do the same thing. 16.1 milliamps, 0.148 K ohm. And then V3, 16.1 milliamps, 0.148 K ohm. So here are my equations, and I'm going to go ahead and do the math. So I do 16.1 times 0.327, I get 5.26 volts. So I get 5.26 volts. Of course, you'll get something different, but go ahead and see what you get. And then do the same for each one of those. So then I get 2.38 volts, and then another 2.38 volts. So those are my values that I got. Now, as a check, add these up, because they should add up to what? The volts across here, plus the volts across here, plus the volts across here, should add up to 10. So I'm going to add up real fast just to double check. I got 5.26 plus 2.38 plus 2.38. I add it up and I get almost, you can't see my calculator, but I get almost 10 on the nose. I get 10.02. So do that as a check. So go ahead and get these calculations down. And make sure that your voltage drops add up to the total voltage. I got 5.26 volts, 2.38 volts, 2.38 volts. So I'm going to give you another minute to go ahead and get yours together. And then we'll move to the next part. So for the next part, what I want to do is verify this on the actual circuit. Let's verify to see if we actually come up with the values that you calculated. And this is pretty much the way you do a lab. What you'll do in lab is you'll do your theoretical calculations like we did here. You'll build the lab and then you'll measure it to see if the theory agrees with the actual circuit. So now I'm going to bring back my circuit build that I had from before. And if you remember, we had set our power supply to 10 volts. And now we're going to measure, and I want to verify that I do in fact get these voltages that I calculated. So I'm going to take my meter, and it may not be in the order that I calculated, but I should have 5.26 volts, and then 2.38 volts, and another 2.38 volts. So I'm going to put this meter here. I don't know if you can see the meter or not. I'm going to put this, since I know I want to measure something lower than 20, I'm going to put that down below 20. And I'm now going to measure across my first resistor. I'm looking for 2.38 volts, 2.38 volts, and 5.26 volts, or something close. If I go across here, I got Or I got my leads reversed is the reason I'm. Okay, this is a little off. I don't know why, I might have picked up the wrong resistor. So what I'm gonna do is, let me just measure the other two. You go ahead and measure yours and see how close it is. Yeah, mine are a little off. I got I calculated 2.38 and I got 2.3 there. I got 4.1. These are a little off. I'm not happy with that. So let me just double check my resistor values just to make sure I didn't, and my voltage value. I'm going to go in and just double check I didn't get something. Oh, you know what? I'm not measuring. Well, yeah, I am. Let me measure my resistor values again. If you go in, you see what I'm doing. I want you to measure to make sure that your theory. Okay, so I got 148 and 148 and 327. So my resistors are good. Let me check my voltage again just to make sure I didn't turn the knob when I move this. Make sure I'm still at 10 volts. Okay, I lost my connection in my resistor. All right, so right now I'm not getting a reading, and then I see my wire is out. So I'm still at 10 volts. So at 10 volts, I don't know if you can see the meter, but I'm still at 10 volts. And my resistor values read good, so I'm gonna go back in here and measure my voltage drops again. I calculated 2.38, 2.38, and 5.26, and what I got was, on this first resistor, the ring is kind of jumping around a little bit, and that might be my meter. It might not be sensitive on these lower voltages, but looks like it's measuring. Let me go down to millivolts and see what happens. Nope, won't do it. So my voltage is a little off. I'm wondering how yours compares to mine, but I got about 2.1 volts. It should be 2.3. I guess that's close, but I would like it to be closer. So I got 2.1. I got another 2.1, and this one should be 5.26. It's actually coming out at 4.7. So you guys were not able to see that on my meter, but you look on your meter to see, to measure, to see if your value is closer than mine, or are they off, or what is it? But from the circuit, they should be close. So I don't know why mine are off a little bit. Maybe because I only paid $20 for my meter. All right. So I'm going to turn this off, and I think that's going to be it for today, guys. So let me just let's go back and talk about what we looked at today, and just let's envision what this report should look like. Now, when I say report, I'm not looking for anything major, more like a summary. So the first thing we did, we went through and we talked about the digital multimeter. We talked about how to set it up to be a voltmeter, an ammeter, or ohm meter. We talked about the fact that when you do that, you always use the common input. There'll always be a connection to the common input. But the red wire on the meter, where you connect that depends on what kind of meter you have hooked up. If you want a voltmeter, you plug it into the input where the V is. If you want an ohm meter, you plug it into the input where the ohm sign is. If you want an amp meter, you plug it into the input where the amp mark is. On my meter, all three were in one input. Or most meters is not like that. There's usually a separate input for current. So yours may or may not be like mine. I don't know. We talked about how to do a continuity check. That's the simplest check you can do. And basically, the continuity check lets us know if the connection is a continuous connection or open connection. If it's a continuous connection, we say we have continuity, and that means there's a complete path through which current can flow. If I have no beeping on the meter, then that means I do not have continuity and I have an open or broken circuit. So I can use that to do a very simple test called a continuity test or continuity check. We looked at the prototype board and tried to understand how the rails run and how to connect up, do a basic connection of resistors on the prototype board. So we talked about the way the rails run and the valley and all of that stuff. We looked at the trainer, and we just kind of quickly looked at how to set up a power supply. And to do that, we use the common input on the bottom as a negative lead, and then we use the white positive volt output. I said input; those are outputs as my positive leads. And then by adjusting rotating the knob in the lower left-hand corner, you can adjust that voltage. And we measure individual resistors with the ohm meter. We hook those resistors up on the prototype board to make sure we understood how to make a connection on a prototype board. To check our connection, we added our total resistance to see what it should be, and then we measured the total while the resistors were plugged on the prototype board. And so if you got the reading that you calculated, you know that you had it hooked up correctly. If you didn't, then you didn't have it hooked up correctly. Once you've done that, we adjusted the power supply to 10 volts, and I asked you to do a circuit analysis to measure or to calculate your current and calculate your voltage drops, and then we compared the actual circuit to the theoretical circuit to your calculations. And hopefully they came out close. Mine were a little off, but I don't know why, but maybe yours were a little closer. So what you need to do is just kind of, hopefully you made like a little outline as we were going through. You definitely have a circuit diagram and some calculations you can add to your report. And I would like you to take a picture of your circuit build so I know that you actually went through and did this. So whatever your final circuit looked like, take a picture of it and include that in your report. So all you got to do is write a summary of what we did. Again, it doesn't have to be every detail, but just kind of an overall synopsis of what we did, and include in that report a picture of your circuit build and the calculations you did to check your circuit build. Anybody have any questions for me? Let me go back to my, hold on a second. Let me go back to the PC. Okay. Now you guys can talk now. Do you have any questions for me?
I don't have a question. I did end up with a difference in voltage, roughly about the same as you did.
Okay.
About 0.18, something like that, volts difference, roughly.
Okay. Now, I don't know why I ended up with that difference. Now, it could be, I suspect one or two things. So it could be that the trainer doesn't provide enough current. If we know what the current, and we didn't measure current, that would have been a good thing to do. So if you guys want to measure current, you can. I was going to talk about how to measure current in the next lab. The thing about current, if you measure it the wrong way, you can mess your meter up. But if you know what you're doing, you want to measure the current. I suspect that the trainer may not be able to put out the proper amount of current for what we're doing. So my current wasn't really too high. It was not quite. It was only 16 milliamps, and these things should be able to put out 16 milliamps, but either the current was off or my meter had some kind of faulty reading. So I'm not sure which one, and I'm not going to really. They were close enough to where I like them to be closer, but they were close enough to I think where I proved my point that if I add up all the voltage drops, they add up pretty close to the total voltage. So if yours was off, you might want to write about what you think that might be, why it was off. And we'll see on the next lab how our values compare. So basically, as long as you did the lab, you should be in good shape. Anybody else have any questions? Let's see, we got Davey. Who else is out there? Danny, Ronnie, Tim.
Hey,
I got people.
when I did mine, I was able to get my resistance after I did the whole circuit, but it never. I even switched my dial. Every time I tried to do voltage, it just gave me a 0. But if I switched it to resistance and checked each of the resistors, I could still do that. But I don't know if I didn't have it hooked up correctly or what.
So you're saying, okay, who is that talking?
Tim.
Tim. So you were never able to measure a voltage drop?
No, I measured the voltage between the two wires and got it to 10 volts.
Okay.
But once I added, and I had all that in, but once I tried to measure the voltage across each resistor, it didn't give me a number. It just kept saying 0.
Can you, now when you measured the total resistance, did that show?
Yes.
Okay, do you still have the circuit in front of you?
Yes.
Is there any way you can snap a close picture of it with your cell phone and text it to me? Let me look at the circuit.
Yeah.
Okay, you got my number, right?
Yeah, give me 1 second. I'll send it here. In
Okay, go ahead and do it. I got something I got to take care of. It's going to take me about a minute. I'll be right back.
Okay.
And you go ahead and do that. And if anyone else has any questions, I'll be right back. Okay, let me know when you sent that picture.
Yeah, I sent it already. It should be there now.
Let me go to my, okay, can you see this?
Yes.
So right here, oh no, okay, I see what you're doing. Now that's okay. I see what you're doing. So you got the wire going into, yeah, that's okay what you have there. And that's okay. This, oh, right here though, see right here? That needs to be here.
Okay, so it just needs to be moved up to the
Yeah,
top row.
this is coming there. Move that up one time and then see if you can get a read.
Okay, give me 1 second.
Yeah, take your time.
Yep, that worked. I got the reading. It's about the same as the 10 voltage, so that did the trick.
Okay, so just, you don't have to do it over, but when you do a report, just compare, see how close your values are, and whatever it is, it'll be close enough. Anybody else have any questions before I sign off? See Danny, Davey, Ronnie. I guess was I talking to Tim? You guys okay?
Yeah, I'm good. But so do you just want us to email this report to you?
No, I'm gonna make a link.
Okay.
When you get it ready, if I don't have the link ready, send me a text and say, hey, I need the link. But I'll make a link where you can upload it. So I owe you a link for your Tesla paper, a link for your magnetism, and I'll do a link for the lab. Are you gonna? Yeah, I'll do it. And if you get it done before the link appears, just send me a text and say, hey, you're ready to upload it, and I'll do it right away.
Okay, thanks.
Okay. Anybody else have a question? Okay, well, I'm going to end this session, and what's today? Today is Tuesday, so we'll come back on Thursday, and we'll continue. We'll do another part of the lab. So you guys have a good rest of the day, and we'll talk on Thursday. I said Tuesday, I meant Thursday. See you later.